Okay, Assalamualaikum and good morning. So this is your final lecture uh, for thermal power. So what I'm going to teach you is a basic concept of AC circuit. So in this topic, previously all you have covered is only on DC circuit. Now I'm going to cover you on AC circuit. So basically AC circuit ni yang sentiasa kena pakai on your daily life. So basically yang arah kamu punya socket power at home or di sekolah yang kamu lihat yang ada power point untuk kamu masukkan plug itu kena pakai AC punya power. DC power yang selama ni yang kamu buat in circuit, DC power ni is only berpakai kalau kamu, for example, laptop. Kamu punya laptop, kamu ada charger kan di sini. So this, for example, this is a dinding. Ini dinding. Kamu connect this one kemari. And then ni kamu punya laptop charger. And then di sini baru bersambung arah kamu punya laptop. So dari sini, this is AC punya AC power. Once ia masuk to this laptop, it is converted into DC power. So basically ada kena panggil namanya rectified. You rectify from this AC to DC. So now we want to look into arah AC punya circuit. Okay. So as an introduction, direct current is used for supplying a small amount of electrical power to the customer. Day by day, demand of electrical energy is increasing due to increase in industrial sectors and other social activities. Only AC power can meet this increasing demand. Therefore, engineering students need to be familiarized with the alternating current and voltage systems. Alternating current generator is used in the power station to generate AC voltage. In the power station, water, natural gas, coal, and nuclear fusion are used as a fuel. So, basic definition. 3 standard waves, as shown in figure 1, are used in the AC circuit for making analysis. These are the triangular, sinusoidal, and square waves. There is another waveform named as sawtooth waveform, also used in AC circuit for analysis purposes. So in AC signal, normally typical kena pakai these 3 types of waveform, but for my lecture I will only focus on sinusoidal waveform because ani yang this sinusoidal waveform saja yang normal kena pakai arah power station. Kalau masa kamu during power station, you will see AC signal tu ia punya waveform is a sinusoidal waveform. So definitions of waveform. Waveform is the shape of the curve obtained by plotting the instantaneous value of voltage or current as ordinate with respect to time as abscissa is called the waveform. So basically, this is a waveform, this one. Okay. So this waveform sebenarnya plotted, it is plotted based on signal provided by the generator. Bukannya diorang terus-terus buatnya, this signal dari mana diorang dapat. So this signal is plotted in terms of time. So let's say it at time equal to 1, at t equal to 1, berapa ia punya voltage. At t second, berapa ia punya voltage. At this t second, berapa ia punya voltage. So from this point yang dorang catat, they found out that the voltage from the generator is a sinusoidal waveform. So dari sana ia punya existing of this sinusoidal voltage waveform lah. Okay. So ada lagi sebuting namanya instantaneous value. So this instantaneous value is also maksudnya the value of the voltage ataupun current, it depends on time. So let's say we want to look at when time t sini equal to let's say 90 second. At 90 second, berapa ia punya voltage? So we can see that the voltage di sini is maximum. So we can say that the instantaneous value of the voltage when the time is 90 second, it is the maximum value. Now frequency. Frequency is the number of cycles that occur in 1 second, is called the frequency. It is measured in cycles per second or hertz to honor the scientist Heinrich Hertz. The frequency is related to time period by the following relation. So frequency, you punya formula is 1/t. So if you look at this diagram, normally one cycle is for 50 Hz nya. For 50 Hz yang di Brunei, dia punya frequency is 50 Hz. So in 50 Hz, normally the cycle, the one complete cycle is 20 millisecond. Apa maksudnya one complete cycle is the sinusoidal waveform itu ia punya complete form. So kalau dari sini sampai ke sini full ke tidak, complete cycle ke tidak, the sinusoidal. We cannot call this sinusoidal kalau ia sampai sini saja. Sinusoidal is you need to complete dari sini ke sini. So if you complete the cycle of the sinusoidal from this point to this point is we call one complete cycle. So if you have one complete cycle, itu kena panggil namanya period. So F is equal to 1/t. So if you look at this diagram, let's say your punya complete cycle is 20 millisecond. So F is equal to 1/20 millisecond. You should get 50 Hertz. So cycle, one complete cycle set of positive and negative values of an alternating quantity within a time period is known as one cycle. One complete cycle corresponds to the 360 degrees radians or 2 pi radians. Peak value. Peak value is the maximum value of the waveform called the peak values. Normally the peak or maximum value represented by the uppercase letter Vm, Em, and Im. So if you look at this diagram, this Vm is ia punya peak value. And then ada lagi kena panggil namanya peak to peak value. It is the sum of the magnitudes of positive and negative peaks of the waveform. It can be calculated as V peak to peak. So basically Vm di sini sama Vm di sini kamu campur ya dengan this modulus gunanya you will have kalau kamu punya negatif di sini, ia jadi positif. So ia jadi 2 VM. Okay, so phase. Alternating voltage and current waveforms are continuous in nature. These waveforms continue after one cycle depending on the generator operating condition. Figure 3 represents the sinusoidal current waveform with a phase angle, and the equation of this current waveform is this one. So if you look at this diagram, let's say ini kamu punya current waveform, ini kamu punya voltage waveform. Okay. So if you look at this voltage waveform compared to dengan current this waveform, this current waveform start mula naik lebih awal compare to dengan this voltage. Voltage start dari 0 second, while this current ia start at this point. So basically sebab tu ia di sini plus. We can say in this diagram the current leads the voltage, ataupun the voltage lags the current. Sama saja ia punya definition. We can say that the voltage is lagging compared to the current, ataupun the current leading the voltage, because at this point the current ni ia start lebih awal compared to dengan this voltage. So ini kena panggil juga phase difference. Phase difference is the phase angle with sign, is an important parameter to identify the alternating waveform with respect to each other. Let us consider the following voltage and current waveforms. So di sini, this is the VM. Ini ia punya VM yang biru. So ia ada angle pasal ia start dari 0. So IT, since ia leading, ia start plus dengan this angle. So we plus ia dengan this angle. So basically the current is leading the voltage. So let's look at a quick example di sini. So an alternating current I is given by IT equal to 141.4 sin 314t ampere. So this current is the instantaneous current. So if you look at this value of the instantaneous current, this is ia punya peak value. And di sini is ia punya, this is ia punya omega. So you punya question di sini, what is the current maximum value? So you know that the peak value is this one. So you can just put the current maximum value is 141.4. Now ia mau what is dia punya frequency. Frequency is equal to omega equal to 2 pi f. So which one is dia punya omega? Omega is this one, 314. So f is equal to omega divided by 2 pi. So you get 50 hertz. So time period. Time period is formula tadi. Formula for frequency is equal to 1 over t. So you can manipulate this formula, jadikannya t equal to 1 over f. You get 20 millisecond. Now di sini lagi nya, what is the instantaneous value when t is equal to 3 millisecond? So let's say for example di sini, ia mau what is the value of this current kalau ia 3 millisecond lah di sini ya. Let's say for example here 3 millisecond. Berapa ia punya value of this current? So in this example, you can just key in yang this equation ni, yang this equation yang this equation you insert di sini 3 millisecond. So di sini ia punya jadi 3 millisecond. So if you key in all this number to your calculator, you should get this answer. Kalau kamu belum dapat this answer, you need to change kamu punya calculator mode in radian mode. How to change here jadi radian mode? Kamu tekan shift and then plus mode. Di sana kamu boleh ubah ia punya, ada berubah jadi ia punya antara degree ataupun radian. So kamu pakai radian. Okay, so this drill problem tadi kamu ada phase angle yang ni, kamu ada this angle. So questionnya di sini, an alternating current I is given by IT equal to 9 sin 7 140. So this is dia punya peak value. This is dia punya omega, and this is dia punya phase angle. So the current, so you need to find out what is the current maximum value. So this is the peak value. So what is your punya frequency? Frequency is equal to omega is equal to 2 pi f. Therefore, f is equal to omega divided by 2 pi. So what is the time period? F is equal to 1 over t. Therefore, t is equal to 1 divided by f. So you must cari di sini what is the instantaneous value when the current when time is equal to 2.2 millisecond. Compare dengan tadi, kamu just masukkan number this t ke sini. Okay, so di sini kamu ada lagi satu extra parameters which is namanya phase angle. So phase angle di sini is in degree mode. So this degree you need to change jadi radian. So how to convert this into radian? Dia punya formula is degree angle kali dengan pi divided by 1 over 80 degree. So once kamu sudah dapat convert this degree into radian, barutah kamu masukkan this value all dalam kamu punya calculator. With this convert jadi radian, then you will get let me check the answer first. Berapa you punya jawapan? I don't think it is it correct 8.5? Let me check first. Okay, so it is correct 8.5 millisecond, 8.5 ampere. Okay, so ada lagi the next one. In AC, you normally here root mean square namanya. So apa gunanya this root mean square? So basically gunanya this root mean square is just an analysis tools in order to know that what is the stable voltage for the AC signal. So for example di sini we want to know berapa ia punya average value for this AC signal. You cannot say you punya voltage is let's say ani you punya peak value 350 volt. Di sini you punya value 250 volt. Di sini value-nya 150 volt. So indahkan kamu begitu value-nya ani all the time. The value-nya di sini all the time. Value-nya di sini all the time. We do not know kalau ya AC value ni berapa voltage-nya sebenarnya yang kira consistent voltage-nya. So based on this waveform, we calculate berapa ia punya average based on this shaded area. Berapa ia punya average. So kena panggil namanya root mean square. So after this root mean square, you will see that we assume that ia punya value itu macam mana jadinya terus. Kira straight. Kira karena compress all this value ke atas. So ia jadi macam mana? Root mean square. So this root mean square, we normally represent ia macam DC value. Kira macam DC value, more stable voltage. So a formula for root mean square is this one. For this formula only applies to sinusoidal waveform. So if IRMS is equal to IM divided by root 2 and for voltage VRMS is equal to VM divided by root 2. So for the phasor diagram, in terms of phasor diagram, let's say for example kamu kena bagi this value for instantaneous voltage. So in order to draw the phasor diagram, you require magnitude. You require magnitude and angle. So based on this value, you need to know berapa you punya magnitude. So you punya magnitude is, you need to know what is you punya VRMS and what is you punya angle. So magnitude-nya is VRMS magnitude equal to VRMS. So VRMS is equal to VM divided by root 2. And you punya angle is this one. So VRMS is equal to 170 divided by root 2. You should get 120. And then berapa angle-nya? Angle-nya is 30 degree based on this value given. So we set reference point as 0. Ini you punya reference point, kosong. So since you punya angle 30 degree, so kamu just buat 30 degree and then kamu draw you punya magnitude arrow. So you punya magnitude is 120 and then angle-nya 30 degree. So this is just an example on how do we represent this value, this voltage value in terms of phasor diagram. So another example di sini lagi. So di sini kamu punya value is 70.7 volt, angle-nya 45 degree. So kamu nampak di sini you punya angle is negative. Since you punya reference pointnya di sini is kosong, so the angle is negative. Angle-nya di sini kamu lihat negatif kan? Kalau ia negatif, ia will ke bawah. So ke bawah, and kamu draw ia punya magnitude arrow which is 70.7. So you can look at this more example here. If you do not understand, you can ask me in the class later on. Okay, so I will continue this in part 2. Please watch the next video. So we'll see you on the part 2 later on. Okay, thank you.